All right, so in this video, we're going to talk about error handling. All right, and to do this, we're going to define a simple function and we'll kind of build up the error handling capabilities within that function. All right, and let's say that what we want, let's kind of think through this. So our function is going to take in two lists. Let's say my list 1, let's say 1, 2, 3, 4, and list 2. So we're going to write a function that will take in two list objects, and what we expect to get out, so I'm just going to put expected output right here, and I'll comment that out, is going to be another list where the entries are going to be the element-wise sum. So for the first entry is going to be the sum of 1 and 5. So the things in, or the values in index position 0 of the two lists that we passed. 2, 6, 3, 7, 4, 8. So we would have a list that returns 6, 8, 10, and 12. All right, so that's what we are going to do. So let's write this function real quick. So I'm going to define a function called sum2list. All right, the first argument that it expects is list 1, and this is going to be a list, and we're expecting it to be integer or floating point values. All right, let me put my comma at the end of that. And then a list 2 argument. Again, that's going to be expected to be a list of integer or floating point numbers. All right, and what it's going to return is going to be a list of integer or floating point numbers. All right, so what we're going to do is I'm going to demonstrate just how we can do error handling in Python, maybe give some information back to a user that was maybe using this function and did not have maybe the input that they passed, the arguments that they passed or not correct. So first let's finish building out the function. So I'm going to make an object called summed_list, and then I'll say for item 1, item 2 in zip of list 1 and list 2. We are going to append to our sum list item 1 plus item 2. And then at the end of the function, we are going to return summed list. All right. So let's just double check our function real quick. So if we call sum2list with our mylist1 and mylist2 objects, we in fact get our expected output. All right, so this works well. So we've defined a function that meets our use case. And again, the key thing with error handling or exception handling and whatnot, as it will be called in Python here, is going to be that, we write these functions, and a lot of times you might be using your, just using the code in a very controlled environment, but a lot of times you're going to be sharing this with other members of maybe a team. And even though you've done the best that you can, you've got type hints, you've been very explicit in how you've defined this function. Sometimes users can pass things that are unexpected, and that could cause the program to quit running. And maybe that's not, definitely a desired result. Maybe we would like for the program to run to completion and maybe give some helpful error message or some helpful message to the user. But ultimately, exception handling is going to be a way of kind of safeguarding when things happen that are unexpected, that you didn't anticipate, to allow your program to run to completion. A lot of times I encounter this when working with interfaces to the web. So a lot of times, you might be writing code that, makes HTTP request to some type of a web or, website or an API that's exposed via the web. And, sometimes servers can go down and you might be expecting to receive something back from that request, but due to, some type of network condition, you get nothing. And, it would be definitely undesirable in those situations for the code to, just blow up and stop running because something on the server side prevented you from getting the data that you expected back. So I'm going to be showing this in the context of, a function that we built, but just know, there's a lot of general much more use cases for this particular technique. And there are a lot of situations where your code could be perfect, the people are using functions correctly, but you're depending on some external service that maybe just doesn't provide data due to some unforeseen or uncontrollable circumstance. So again, with that kind of pretext, let's continue. All right, so we see that right now our sum_to_list function works correctly when we have input that is numeric, and we can even check it here. What if we gave it a floating point number in list 2? All right, so it's indeed working as expected. All right, but what if we were to say something like this? So what if for some reason, maybe again, we're pulling this data from some type of a web interface and some type of a list, and we just want to take back these list pairs and sum them up. And let's assume that for one of those lists, we get a none value. So maybe whatever that web service is, they provided no data back. I'm going to delete that expected output. So now when we run this, we're going to get a failure, right? So we're going to get an error arise. In this case, it's a type error, and it's telling us, hey, the operation that you're trying to do, which is a sum between an int and a none type, is not defined, right? So that's not supported. So we would have an error at this point, and the code would cease to run. All right, so the way that we can do exception handling in Python is we can use try and except statements. Okay, so what that would look like is this. So this is the element of our code that's giving us the problem, right? We can actually see that here in the error message that's returned. So when we did sumList.append item 1 plus item 2, that's what's giving us the type error, because again, item 1 in this case is going to be the first element of my list 1. So it's going to be an integer 1, and then item 2 is going to be none, right? And it's saying, hey, you're trying to add an int to a none type, and that's not supported. So this is where the error is. So what we're going to do is we're going to use a try except statement to essentially first try to perform the operation, and if some type of error or exception is encountered, what it will do is it will essentially just abort trying to do that computation and doing that list append and print some type of a message to the user. All right, and the way that you would do this is you would say try, all right, and then what we want to do is we want to nest that statement that was potentially error prone underneath that try statement. All right, now if we were to just run this as is, right, so if I redefine my sum_to_list, it's going to give me an error. It says, hey, whenever you have a try, I'm expecting either an except or some type of a finally block. All right, so you can't just have try alone. All right, so you have to do, give Python some guidance of what should be done in the event that that try fails. All right, and the most common way to do that is with an except block. Okay. So what you can do here is if we say except, we can, typically if we just want to continue on operation, we can just say pass. So if I run this now, that works, but notice that it only returned those 3 elements, right? So in particular, it returned the sum of 2 and 6, 3 and 7, 4 and 8, right? So it tried to do that first add, and it wasn't able to, right? So it said, okay, well, that's an exception. So it kicked down to this except statement, and there was a pass there. So it just said, okay, well, I'm going to continue on. So think of that, almost like, a continue statement that we've seen before. So a pass or a continue statement here. All right, so we've got a try. We did, tried to do this append, and that will fail. So if that we do end up getting an exception at this point, we kick down to our exception block. Now this works as we've just seen, but a lot of times it's kind of bad practice to just put an exception block without any information going to the user that exceptions are occurring. Now it could be again that you're trying to make requests against a very unreliable web service. So maybe using print messages is not going to be, or using the print function to print messages to the screen is not going to be the most helpful thing. Or maybe this is running on some type of server. So you could write these things out to a log, and there is actually very good logging capabilities in Python. But for now, we're just going to print it out to the screen, kind of showing that, hey, something happened that was unexpected, and a particular, sum is being skipped. All right, so you could just put a print statement right here, right, and saying, okay, let's just say the sum of item 1 and item 2 failed. Right, so now we are getting some information. So you can see that we're hitting this except block right here, and then we're getting that exception and we're printing out some type of message. Oftentimes, you might also want to see the type of error. Right, so what you can do is you can use this type of a statement here. So notice that I'm using that capital E, and that is by design. So I'm saying except exception. And what this is this is just kind of a general class that captures all types of exceptions that can happen in Python. So what you can do is you can say except exception as E, and then out here in parentheses, you can put this phrase. And this looks a little bit archaic. So I'm going to say the type of E, and then you could do underscore name or double underscore name. All right, so get the type of the exception. So whenever you have an exception, what you're doing is you're storing it in a temporary variable E, and I'm grabbing the type of E and getting its name attribute. So that dunder name will capture that name. And let's see what happens here. All right, so it's telling me, hey, we got a type error when we tried to do the sum of 1 and none. All right, and let's just see what it would look like if we were to remove that name. All right, so that's kind of the difference. So the dunder name, it just makes that, that essentially printout for that particular type of error just a little bit prettier. So in this case, it returns it was a class type error, and this might be sufficient. It's a little bit easier to remember this syntax here than doing that dunder name at the end. So, all right, so one last thing that I want to mention. So if you noticed if I were to comment this out and run this, right, so it said, hey, I expected an except or a finally block. All right, and what you can do, so in addition to except, you can also define a finally block. And what will happen is regardless of whether or not an exception occurs, it will enter this finally block. So let me just print right here. Let's say in finally. Let's just say finally area. All right, so what will happen is regardless of whether or not an exception occurs or not, so like in that first case, right, when we try to sum 1 and none, that fails, but we always will go to that finally area. And what this is really made for is imagine that when you're doing the try, because one thing to kind of recognize is Python is running this top to bottom. So imagine that right here, you maybe opened a file, or opened a file connected to some type of a server, connected to server, or other things, right? So, etc. Right, so it could have been that before you could have, retrieved this data, maybe you were in a for loop, maybe you connected to some type of server, you opened a file, and then if an exception occurs, it could prevent proper closing of that connection to either that file or that server. So if you were to go through this try, maybe it does the open, and maybe you have the code right here. You would think about putting the code right here to close that connection. All right, but the key thing is, since Python is running this top to bottom, if you open here and you get an exception when you try to do that sum, as was the case when we were getting those errors, you're never going to hit that piece of code that closes that connection. Right, now technically, you could put the close connection code in both the try and the except statements, and that would ensure that that is going to be done regardless of the case. But in that case, you're kind of repeating code, right? Because you're going to put that same logic in both the try and the except, and if you ever need to change that, you've got to change it in 2 places. All right, so instead of doing that, you could just define that close connection code down here in your finally block. All right, so in this case, regardless of whether it was a success or you had an exception raised, you're going to enter this finally block right here, and you are going to close that connection. All right, so that's the use case for the finally area. All right, let's look at one other thing related to error and exception handling. So right now, let me just restart the kernel and clear all outputs. All right, so I'm going to go back to a list that is valid. So here is our original case. So my list 1, my list 2, and that works as we would have expected. All right, so what this has done up to this point is we've said, hey, all right, so if we try to do that sum and maybe they passed us a string or some type of a none type where we can't sum that with a numerical type, we want to print some type of a message to the user, and then we want to just pass, right? We want to just move on and try the next computation, right? Now, again, it could be very well, I am going to mention this at this point, you may very well want the program to fail. And if it's mission critical that, every item gets computed and you want to be, aware of any error or stop the computation if there's any error because it might force a bug somewhere else in the program, it's okay. You don't have to use the try and except. You could let the exception arise. So that way you could go back and troubleshoot exactly where's that bad data coming from. But in this case, and again, when you're working with web or you're working with databases and making requests, a lot of times it's going to be just outside of your control, and there is always going to be some likelihood that the server, the database, might fail to respond. All right, so this worked well, right? So we can see if I were to then go and make that none again, right? So that's how that works. All right, but what it doesn't catch is this case. So what if one of our lists turns out to be longer? All right, so again, I'm going to do restart kernel and clear all outputs. All right, so this now is returning a list, okay? But originally when we passed in, list 1 had 4 elements, list 2 had 5 elements. So what this did is this just returned the first 4. All right, so maybe we want to know that, hey, there was some type of mismatch in the data. Maybe, it's the services that we're relying on, they should be providing data back in exactly the same shape or exactly the same length. And in this case, with just try and accept, it's going to allow that to occur. It's not going to catch that because technically it's not an error. It's just the result is not what we expected. All right, and the reason that this is happening is because of the way the zip function works. So if you pass in, 2 iterables, it's going to zip them together and return those tuples. There's another video that talks about the zip function and how that behaves. But it will return those tuples, and then basically it's going to stop at the length of the shortest. So in this case, it's returning 1, 5, 2, 6, 3, 7, 4, 8, and it stops because that's the end of list 1, and list 1 is the shortest. All right, so that's what's going on. But again, that there's no error, there's no messages because, the numeric types are being, we were able to sum the types that are in the list. So we never hit an exception with our try and accept logic. All right, so one thing that I do like to do, especially when you're doing data work and you're expecting, certain formats of data coming in, what you can do is you can add another statement called an assertion statement. All right, so what that would look like is this. All right, so we can write a statement and put an assert, and this all needs to be on one line. So we can put a statement that says, hey, I want to assert that the length of list 1 needs to equal the length of list 2. All right, let me restart the kernel, clear all outputs. Now when we run this, now we're going to get an assertion error. Okay, so we do get an assertion error here that's saying, hey, you know what, something is very wrong in the inputs that you provided, and it's going to halt the execution. Right, so you might think, okay, well, you were just showing me how to get around errors, and then now we're showing how to raise an error based on that. So when do I use things? Again, try accept. If you're getting data from users, if you're getting data from services, and you can't guarantee that they will always provide the right types, and it's okay for program execution to continue skipping those cases where errors might have arisen or arose. So that's kind of the use case for try and accept. And an assert statement is, okay, well, for this function to for whatever this computation is to work properly, these conditions have to be met. So in those cases, you would want to come up with an assertion statement based on those conditions that will ensure, okay, these things are, they match my expectations of what we should be getting before we do computation. All right, now you can also provide just a little bit. You'll notice right here, this assertion error, there's essentially no text right here. We just say, hey, we got an assertion error. So what you can do is you can add some text. You just put a comma at the end of the condition you're asserting, and you say the two provided list have different lengths. And now your assertion statement is going to have a little bit more meaningful message. All right, so again, let's just go back and check. So if we go 5, 6, 7, 8 in list 2, everything works as expected. In this case, if we have one out of place, we get our assertion error. And now if we go back and the data, the lengths of those are correct, but maybe we have a none instead of that 6. All right, it's telling us here the sum of 2 and none failed, and that entry is being excluded. So hopefully that gives you a little bit of an idea of, some additional kind of syntax that you can use as you're writing code to make it a little bit more robust. Make sure that you're getting things into functions, you're getting arguments or data that you would expect. And that will conclude this video.